Hello everyone, my name is Aaron Carmen and I'd like to welcome you back to my series of videos regarding basic circuit analysis. Today in lecture 2 we'll be going over resistors and Ohm's law. Now, previously we talked about voltage, current, and power, and we said that a voltage can be thought of as the driving force behind a current. Now we're going to actually quantify this relationship using Ohm's law. So Ohm's law, spelled O-H-M, Ohm's law, is as follows. If we want to know the voltage across a device or any component inside a circuit, it is going to be equal to the current through the device, I, times R. Now R is something that we haven't talked about yet, and R is the resistance. So let's make a new definition called resistance. Now resistance is qualitatively thought as the opposition to current flow. So the opposition to current flow. So last time, like we had said, that voltage is the driving force behind a current. Now how can we tell how much current is going to flow if we have a given voltage? And the resistance is what's going to determine how much current will flow based on that given voltage. Okay, so this means that if we just look at this equation, just in a very simple manner, if we increase the voltage, the resistance will stay the same because it's a characteristic of the component. If we increase the voltage, the current has to increase for that equation to still be true. So that essentially means if we increase the voltage, more current will flow. So in order to provide resistance in a circuit, we use what's called a resistor. And a resistor provides resistance. Now the circuit symbol for a resistor is as follows. We have just a line and then some jagged diagonal lines. Okay, so this symbol here is a resistor in a circuit. Okay, so resistance, let's go back up here. Resistance has a unit of ohms, and we'll also use a capital Greek letter omega for that. So if I were to say that this resistor has 10 ohms, then that means it's a 10 ohm resistor. Okay, so let's just go ahead and look back over at voltage and current sources before we start looking at some simple examples. So let's write down sources, and these provide either voltage or current. And a lot of times this voltage or current is fixed, but it can also be variable. But at the moment we're just going to be looking at fixed voltages or fixed currents. So if I have a voltage source, we use a circle with a plus or minus to represent the polarity of that voltage. And then we also have the lines coming off of it. And then it'll have a value here, so let's say 10 volts. That means that from here to here, there is a 10 volt rise, or from the top to the bottom, let's just, from the top to the bottom, there is a 10 volt drop. Okay. So similarly, we have a current source. And for a current source, we just have a circle with an arrow in it. The arrow represents the direction of the current, and we have the value of the current. So we could say 1 amp is flowing upward. So that means that it's going to be 1 amp in this direction. Okay, and it's going to provide that current to the circuit. Okay, so voltage sources, current sources, and resistors. That's what we're going to be looking at right now. Okay, so let's do just a quick little simple example. So let's say that we have a circuit. We have a 10 volt source, okay, and then we have a resistor. Okay, and these are just the only things in this circuit, and they're connected together like this. Okay, and let's say that this resistor is 10 ohms. Okay, so we want to know what the current I is. So we want to know the current I. And that's the only thing that we don't know about this circuit, because we know the voltage and we know the resistance. So how can we find the current I? Well, the answer is we can use Ohm's law. So Ohm's law again is V equals I times R. Okay, we know V, we know R, so all we need to do is solve for I. So then we can get I by itself and say I is equal to V divided by R. So that's 10 volts divided by 10 ohms. That's going to give us a value of 1 amp. So we're going to say that if we have this circuit here, that 1 amp of current will flow through that resistor. Okay, so this is a pretty simple example. So let's try another one. So let's say that we now have a different circuit. Let's say that we now have a voltage source here, the same resistor. Okay, so now this resistance is only 5 ohms, and let's say we still have a 10-volt source. So now we still want to know the current I. Okay, so this is another application of Ohm's law. We just use V is equal to I times R. Okay, we know V, we know R, so then we can say I is equal to V divided by R, and that's equal to 10 volts divided by 5 ohms. So this is 2 amps. So you can see that whenever we reduce the resistance by half, okay, we cut the resistance in half, twice as much current flows. Okay, so this makes sense. The current that flows is inversely proportional to the resistance. So if we decrease the resistance, we will increase the current. Okay, so now let's try one more example. Okay, we'll do this example a little bit differently. Let's say this time we have a current source. Okay, and we have the same configuration where we have a resistor here and they're all connected together. Okay, and let's say that there is a 2 amp current source here and this is a 3 ohm resistor. Okay, now we want to know the voltage V here. So the voltage across that resistor. Okay, so this source, it will provide voltage, but it's not a known voltage. This source here doesn't provide a known voltage. It only provides that current. That's the only thing that we know. Okay, so we need to know the voltage across that resistor. Okay, so we can use Ohm's law again. So V is equal to I times R. This time we know I and we know R. Okay, so that's how we're going to solve for the voltage across this resistor. Okay, so we can say V is equal to 2 amps times 3 ohms. And that means there's going to be 6 volts across that resistor. Okay, so that's how we're going to solve for voltage, and that's how voltage and current are related. Okay, so the goal of this video was to introduce the concept of resistance, and you can see that resistance is just the opposition to current flow. So if for example, we have a voltage source like in these examples, if we have this voltage source, decreasing the resistance will increase the current flow. Okay? And conversely, if we increase the resistance, it'll decrease the current flow. So this just means that for a higher resistor, it's going to take more energy to create that same amount of current. So it's going to take more of that voltage to produce the same current. Okay, so this is a pretty short video because this is a pretty simple concept, but it's one that's very important, and we'll look at more details regarding this concept later on, but I think this would be a good place to stop. Next time we're going to be looking at Kirchhoff's laws. So there are different laws that apply to different circuits, and this is how we're going to solve the more complex circuits. And then once we get a good foundation on Kirchhoff's laws, we'll start looking at different combinations of resistors. So something to think about until the next video is if we have a resistor, okay, and then we have another resistor connected to it, is there any way that we can simplify this for it to make our calculations easier? So if we have a resistance A and a resistance B, can we simplify that to make our calculations easier? Okay, so that's something for you to think about next time. Thank you for making it to the end of the video, and I hope that I can see you in the next ones.